So welcome to the 2015 NASA Ames Summer Series. NASA, and in particular NASA Ames, changes the way we see and interact with the world. As a research and technology center, NASA Ames develops novel concepts and approaches to advance NASA's missions. This cannot be achieved without a great team, balanced by a great leadership. Today's talk, entitled NASA Ames' Role in the Future of Exploration, Science, and Aeronautics, will be given by our NASA Ames Deputy Center Director, Dr. Tom Edwards. Dr. Edwards is a graduate of Princeton University with a bachelor's in mechanical and aerospace engineering. He also received a master's and a PhD degrees in aeronautics and astronautics from Stanford University. Also, he has a master's of science in management from Stanford Graduate School of Business and is a Sloan Fellow. He began his career at NASA in 1983, just after finishing the bachelor's. He has had experience both on the technical and management ladder within the center, and prior to becoming a deputy, he was the director of aeronautics at Ames. Please join me in welcoming Dr. Thomas Edwards.
Thank you very much, and thank you all for coming today. I know there's a lot of things going on at the center today, and I appreciate that you took the time to come and listen to me. I also want to thank Jacob for this opportunity. If those of you who've been coming to the colloquia through the summer, you've gotten to hear from astronauts, scientists, project managers, and authors. Fascinating people, and so the grand finale is a manager. So it took a fair bit of courage on your part to come and hear. But I look forward to sharing with you a little bit about how I view this lofty title of the future of Ames's role in the agency's missions. As you probably know, many of you probably know, both me and the center director, Dr. Eugene Tu, are relatively new to our positions. We have been in our positions for just a little over 3 months now. Both of us. And while we're fairly new to those positions, we're fairly long to the center itself. So we have a general pretty good idea of what's going on here, but we are in new roles, and it's somewhat audacious to think that we've got the future figured out already. So this is really just a preview of what's to come, where we see things headed, and looking forward to working with you on really defining the future and looking at how Ames and our assets best fit into the future of where the agency is going. So with that, I'd like to give you a little bit of an introduction to what Ames is doing, and you'll see that my central thesis is that Ames really is the future of science, exploration, and aeronautics. And the reason I say that is that here at Ames, more than any other center in the agency, we conduct fundamental, groundbreaking, innovative research. For that reason, sometimes we're viewed as unconventional, possibly even controversial. And we're also looking at the next generation of technologies that will enable or help us understand things that are really beyond the current day operational time horizons. So we are out there really working in the future, and the rest of the agency is catching up to us in many ways. And that's a heritage we've had for a very long time, and I think it's good for us to proceed with in the future. So to start with, let's think a little bit about what the agency espouses as its future. And there are these really inspirational taglines here that the agency has put out as part of its vision to reach new heights, reveal the unknown, and benefit all humankind. That's really incredible, and that's inspirational stuff. It's part of what makes it really fun and cool to say that you work for NASA and to come through the gate every day and be part of this. That said, those are fairly lofty statements. What does it really mean? So that's what I want to talk about here and get a little bit more specific about it. We've got all these very altruistic goals, but what does that mean? What do we do about that, and where are we going? So the next level of vision that the agency has espoused are embodied in these nice posters with sayings that kind of capture the major areas of emphasis for the agency. They're a little bit hard to see, so I'll go around and touch on each one, and you'll see how they kind of fit together, and they also describe those very nice statements on the previous chart. In the upper left is aeronautics. That's the first A in NASA. It's where I spent most of my career working as a researcher and as a manager. And the tagline there is, "With you when you fly." You'll hear a little bit more about what that means in a minute, but essentially there is NASA technology in every aspect of air transportation and in aircraft. And so when you're flying, you are benefiting from NASA technology. The next one in the middle says Earth right now. And the tagline there is, "Your planet is changing, we're on it." Nice little double entendre there, I like that. And we have our own planet to understand, just like we want to understand planets and the rest of the universe, but we first should understand our own planet, especially because it pertains very directly to our quality of life and our way of life here. And so a major emphasis is to look at our own planet. Then on the upper right, there's the International Space Station, off the Earth for the Earth. And you'll hear a little bit more about the way that that research platform in space is using its unique environment to understand the way humans evolve and how we adapt to varying conditions and how life can survive in microgravity, and that will benefit life on Earth as well as in our exploration activities. Continuing around clockwise, we've got solar system and beyond. And that one says we're out there. And you can just think of any number of missions that have been profiled recently that are understanding the solar system. Most recently, New Horizons. We had a major event here to celebrate the flyby that the New Horizons spacecraft did of Pluto. Coming back around, there's Mars, and this is really the centerpiece in a lot of ways, NASA's journey to Mars. So I'm going to come back to that in just a minute. But that currently is the driving focus for a lot of NASA's work in technology and in exploration. And finally, we've got space technology, and the tagline there is "Technology drives exploration." So we are a technology organization. NASA thrives on technology. We need new technology always to push the frontiers and to enable the capabilities that we need to do ever more ambitious space missions. So that's a quick profile. Now, what I'm going to do in this talk is relate this back to the things that Ames does and look at how we are contributing to the future in each one of these areas as we conduct the research here at the center. Before I do that, I just want to zero in a little bit on that Mars mission, the journey to Mars. And in fact, it really doesn't matter a whole lot whether our ultimate destination is Mars. It sets a focus for us that drives a lot of technology that will be relevant to any destination that we go to. And so it's a lot of times we use things called design reference missions to really define requirements and to drive technology needs. And this would be an example of that, where we're setting a goal of putting humans on Mars in the 2030s and seeing what is it going to take to make that all happen. And it starts on the far left in a regime that we call Earth reliant. This is the regime that's within the Earth's atmosphere as well as up to low Earth orbit, where we can exist in those environments, but we rely intrinsically on regular and routine support from Earth. So we see things like the space station, obviously is an active area of research, And we are bringing up astronauts and supplies on a continuing basis multiple times per year to provide them what they need, to set up the experiments, to bring the experiments and the data back. And we are learning a lot, but we are completely reliant on regular launch access to those areas. In addition to that, we've got commercial cargo and crew. Now we're trying to hand off the domain of low Earth orbit to the commercial sector, where there are a lot of commercial potential. There's also the ability to commercialize the space transportation business to low Earth orbit, and we are in the process of doing that with companies like Orbital Sciences and SpaceX that are now providing launch capabilities to station, and they will also be able to provide launch services to anyone who wants to access low Earth orbit. So we've learned a lot and we've accomplished a lot in the Earth reliant. Now we're starting to turn our focus to that middle ground called the proving ground. Now this is where you're getting a little bit farther out there, where it's more challenging to both send spacecraft, people, payloads, and also to exist out there, outside of the radiation belts into the environment that is characteristic of deep space, with radiation, the potential for solar flares, longer duration missions, and now the first time that the time delay of communication starts to become an important impediment to how you operate, from anywhere from seconds of time delay communicating with the moon to tens of minutes if we were to look at scenarios approaching Mars. And in this regime, we really need to have our spacecraft and our astronauts be more independent. And yet, in this proving ground, we can, in extreme situations, turn control or reliance back to Earth, or we can get back to Earth in a relatively short amount of time. In this regime, we can test out the technologies that will be necessary for us to become Earth independent. So things like novel propulsion systems, and also the crew cargo spacecraft that are going to be necessary to exist for longer durations in space. And finally, we get to the Earth independent regime, where we really need a self-sufficient capability to sustain astronauts, to be able to operate effectively on planetary surfaces as well as in orbit, to fix things that break on ourselves rather than having to go back home for spare parts. And looking at all the various support systems, habitats, transportation vehicles, communication systems, and so forth, that will sustain life in an independent manner. So I took a bit of time to go through this because this really does explain many of the things that we are doing within NASA, and particularly here at Ames. So now let's turn and look at what do we do here at Ames that we really take pride in and that we think contributes strongly to the future of the agency. And we've grouped them into these 8 areas. They're fairly broad, but they don't cover the spectrum of everything NASA does, and they certainly exploit the unique capabilities that we have here at Ames, as well as by virtue of the community that we live in here in Silicon Valley. And I'll have a little bit more to say, so I won't take too long on each one of these. Air traffic management is one of our main heritages here in aeronautics. We're making incredible contributions there. In entry systems, we've been working in entry systems for decades, and we are still the agency leader in developing and testing new technologies. Obviously, our location has given us a great advantage in developing new computing systems and information technologies that have been used to benefit all of NASA's missions. Intelligent and adaptive systems is another area that really was an outgrowth of our capabilities in computing and has been applied to building more and more intelligence into the machines that serve us, whether they're aircraft or they're spacecraft or planetary exploration vehicles. Low-cost space missions. And this is important. It leverages the spirit of innovation that we have here in Silicon Valley, and asking the question, can we do the same thing for less? Now, in many cases, space is expensive, sometimes very, very expensive. But through some creativity and through looking at unique combinations of technology capabilities, we can ask, well, couldn't we do the same thing for a whole lot less? And of course, when you do that, you're accepting more risk. And so what we're pioneering for the agency is developing low-cost, novel space missions, admittedly accepting additional risk, but the payoff is there that we're willing to take the risk in order for a big payoff that we can do science and exploration more inexpensively, more quickly, and we can take advantage of higher technology because of the shorter cycles. So this is a new area that's really taken root within the agency. Aerosciences is a very broad area that applies to using both the experimental and computational capabilities that we have here at the center to model and simulate all types of vehicles, from aircraft to spacecraft, and to use the understanding of physics and the capabilities of digital computing to perform design trades and optimize vehicles much better than we ever used to be able to. Astrobiology and life science, another area that we pioneered for the agency, looking at the origins of life and the existence of life elsewhere in the universe. And finally, in space and earth sciences, we have astronomers, we have earth scientists who are agency leaders in unique missions that help us understand our planet and also the existence of other planets and understanding the universe in the broader context. So these are the general 8 areas that we put forward as where we can make unique, novel contributions to the agency and really propel the agency forward in its missions. There's a relationship then between these 8 and the broad visions that the agency has put out. And so I want to kind of step through some of those and give you a little bit better idea of how we're contributing in each of those areas. So let me start with the aeronautics theme. We said we're with you when we fly. And this is just a list along with some graphics of some of the key areas. I'll just touch on each one very briefly, and then I'll go into a little bit more detail on one of them to give you a flavor of how we're contributing. In transformative aeronautics concepts, we're looking at changing the paradigm of air transportation. Right now we get on a large aircraft that looks essentially the same as it did 40 years ago. It's an aluminum tube with wings. A lot has changed since then, but the paradigm is very static. Now we're at an age where we're starting to look at whether things like personal air transportation is possible, whether we can stop using fossil fuels and make electric aircraft work. These are transformative, and so we're looking at that here at Ames. We are also looking at the operations and safety. I'll say a little bit more. This gets to the air transportation system, but we also use our data analysis capabilities to understand the aviation system and where there might be emergent safety concerns and solve those problems before they result in accidents. UAS, unmanned aerial system, airspace integration is a really big deal here, and any of you who were here last week might have noticed a major event we had down by Hangar 1, which was a convention to address the very fascinating and complex issues associated with this. Concerns not only about how to fly and regulate drones, but also what are the concerns about insurance and privacy and security and safety. It was a fantastic event, brought the community together, and I think it's going to help us make a lot of progress there. I mentioned about high fidelity modeling and simulation. We continue to have a heritage there, and really the fundamental understanding of fluid physics and acoustics to design ever more capable aircraft. Wind tunnels, you can't drive around the center without seeing a few wind tunnels, including the largest wind tunnel in the world, and also one of the busiest and most productive wind tunnels right across the street from the largest wind tunnel. It's the one with the white shell and the NASA meatball on it. That's the most productive transonic wind tunnel in the country, and just about every aircraft that flies in the transonic regime goes through that tunnel. Flight simulators also to assess pilot handling capabilities. We have 3 major flight simulation assets here. And then we have the NASA Aeronautics Research Institute. It's one of our 3 virtual institutes here at the center. Virtual institutes are a novel construct, and I'll say a little bit more about that in a minute. This is what enables us to network and connect with the broader community, academia, and industry, as well as partners around the world, to bring the best minds together to address problems. In the area of air transportation, air traffic management, we've combined our knowledge of how aircraft fly. We had our heritage in aircraft control, so we have a detailed understanding of how aircraft fly, together with a number of other disciplines, including information technology, as well as human factors and operations research, to look at when you have multiple aircraft in the sky, what is the best way to manage those flights so that everybody gets where they want to safely in minimum time. And as a result of this work over the past decades, we have developed decision support tools for both pilots and for air traffic controllers that help them manage the efficient flow of the airspace. Now, looking to the future, we're looking to ever higher levels of automation in that, potentially someday leading to autonomous flight management systems, both on aircraft as well as sort of a central manager that handles all the traffic going around the United States and abroad. So this has been an area of huge success for us. We have transferred our technology to the FAA, who has deployed it, and now when you fly anywhere in the United States, your flight is being aided and controlled by technology developed right here at Ames Research Center, helping you get to where you're going with the minimum delay. I'm not promising you that you won't have delays. I'm just saying it's less than it used to be. And the problem is getting harder because there's more and more traffic in the air, and there are also new constraints that we have to deal with, like noise constraints and having to deal with carbon emissions and minimizing that. So it's an ever-growing problem, but we've also got some breakthrough technology that should help us solve those. In the area of earth science, really a lot of different things going on. I'll highlight the Earth Exchange as one of the major contributions we make, where we're using our high-end computing capabilities and data storage and management to bring in the literally terabytes of data coming from satellites and airborne platforms on a daily basis, to bring it all together and put it into a manageable format so that scientists around the country can access it and use it to analyze, to answer scientific questions, and help us deal with the challenging problems of Earth climate. Airborne science is particularly one that we have played a strong role and will continue to. And the future is really looking at novel unmanned platforms that we have a unique capability here to look at those either as single platforms that are doing surveys, or to use swarms to really understand the complexities of the system that we're interested in, whether it's a volcanic ash plume or sea temperatures and things like that. Sustainability then feeds off of these to look at how do we manage the Earth as an ecosystem, and how do we use that knowledge to build a better ecosystem. And we're also pioneering the use of small satellites and advanced computing to benefit the understanding of our home planet. So this is one of our big UAS. This is actually down at Armstrong. Armstrong Flight Research Center down in the desert of Southern California operates the aircraft. We do a lot of the science payloads and the definition of the missions. So that's one of the big ones. And then on the small end, we've got aircraft that are no bigger than your arm span that can fly very easily and carry small instruments to conduct novel missions. International Space Station, we have a large and growing program in life science. This is, as I said earlier, both about helping us understand life here on Earth, but equally importantly, understanding the life in space, the effects of radiation and microgravity on life, and what we might need to be concerned about for longer-term deep space missions. And so we have developed a capability to deliver life science experiments to the space station, have them conducted very efficiently, and bring down the results. That's a vibrant program. We've also got robotic free flyers. I'll say a little bit more about it in a minute. Efficient crew operations, I'll just touch on briefly too. That's builds off of our work in intelligent systems and autonomy. And what we're doing here is helping Johnson Space Center manage crew time. And it turns out that on the space station, crew time is the limiting factor in many cases for how much science can get done on the space station, because the astronauts on board are busy from dawn to dusk, and they have a lot of those during a day, running experiments and managing them and taking data. And so the scheduling becomes a huge challenge. We've developed some automation technology that is being used by Johnson Space Center to optimize the crew time so that we can get as much science through the station as possible. And that's been a big success story. Spheres is the free flyer that I referred to a second ago. And you can see it's a very clever acronym for a little ball that's a robot, and it helps the astronauts on board the station with routine tasks that can be performed by a computer, but the computer actually drives itself around the station, gets where it needs to be, and does the function that it needs to do all by itself. It's an autonomous system. It's driven by little carbon dioxide pressure jets to move it around. And I think this guy is actually trying to juggle, which is sort of a perplexing concept in zero gravity. But in any event, this idea was started here, and we actually built these systems. The embedded computing is actually right out of a very high-end smartphone that drives the whole assistant there. And so that's something that the astronauts have come to know and love. In space technology, we're also looking at how we can advance capabilities that are going to get us to that proving ground and into Earth independent. We have partnered with a company right out here in the research park to put the first 3D printer on board the station, and we're starting to look at how we could build spare parts and parts that we need, unique parts, in space rather than having to carry everything up. Heat shields, I'll say a little bit more. That's really one of our most famous contributions in space technology. But we're also contributing. We've done a lot of autonomy work for Mars Science Laboratory and the Curiosity rover to help it also be as productive as it can in collecting science. And then we're looking at this intriguing area of synthetic biology. Can we use our understanding of biology to serve our purposes better in terms of producing elements and compounds that we need, rather than having to synthesize them here on Earth and take them with us, to use the best of biology to further our sustainability and our needs in space. And then again, we've kind of done the pathfinding work on small satellites like the ones shown here. So in heat shields, we have developed the materials and the heat shields used for just about every spacecraft that has entered an atmosphere. Every heat shield has had its materials tested here in facilities that we have. This mass of wires here is actually a facility called an ArcJet, testing materials at the temperatures and speeds associated with entry from either from return from the moon or from deeper space. And we've invented some of the materials that have proven to be the most capable. This material called Pika enabled the Mars Science Laboratory mission. It was the heat shield material of choice, was invented here and tested and developed and proven. So we have a long heritage, and we're very proud of what we contribute there. So Mars, where we're headed. We've got a long heritage of work looking at the climate and the environment in Mars, very important to life on Mars. Quick show of hands, how many of you have read The Martian? Okay. How many of you are going to go see the movie? Probably all of you, I hope so. I personally think that should be required reading for everybody who works at NASA. it is fiction, but it is very good fiction, and it actually helps you understand a lot about the challenges of getting to Mars with people. And so understanding the environment, obviously the story starts with a story about the environment, and so it's very important to understand that so that we know what we're going to deal with. Astrobiology, understanding what do we even look for if we're looking for life? What are the markers? What are the precursors? What are the fossil records going to look like in a completely different environment? And so our understanding of astrobiology will inform the types of activities we want to conduct when we get there. Obviously, we're not going to do it all with people. We're going to need teams of robots and astronauts working together. Right now, we've done each one separately. What we really need to figure out is how to deploy a team, mixed initiative team of humans and robots that can accomplish a mission objective very efficiently and in a very coordinated fashion. And of course, the heat shields just need to keep getting better because the entry speeds are higher and the payload masses are higher. And so getting heavy payloads to the surface of Mars is one of the pacing items in enabling the manned Mars mission. It will require capabilities beyond anything that we have now. Furthermore, so I mentioned about the autonomy that we're contributing to the Mars Science Laboratory and helping JPL schedule the science operations of the rover. Great success story there, and we'll certainly be using that as we go forward with future missions like Mars 2020. In addition to that, we have very creative scientists here who develop instruments to meet unique requirements. And one of them here is the one we call CHEMIN, which is an X-ray diffraction spectroscope. That's alone is not unique. Those devices have existed, but all the previously existing X-ray diffraction spectroscopes were far too big and heavy and required too much power to make it onto a payload. What our scientists figured out is how to miniaturize that to the point that we could put one of these on the Curiosity rover. And we won that proposal, built the device, and it is up on Mars working right now and determining the chemical constituents of the Martian regolith to determine if there are markers of things like the existence of liquid water and any compounds that might be associated with precursors of organic life. So that's a heritage that we will also be continuing. Finally, getting into the solar system and beyond, we've got a number of missions that we're very proud to have led here and look forward to a future that continues to contribute. Kepler, I'll say a little bit more about in a minute. Very exciting exoplanet hunting vehicle. SOFIA is the aircraft shown here, the Stratospheric Observatory for Infrared Astronomy. Cut a huge hole in a 747, hope nothing goes wrong. Actually, we did the engineering to make sure nothing would go wrong. Put a big telescope in there and do infrared astronomy from the stratosphere, where you're above 99% of the Earth's water, which absorbs infrared. And so you can make observations that are space quality observations from an aircraft that can return home every morning to be refurbished, resupplied, and we can bring on new scientists. So this is a very active and productive aircraft. It flies out of Armstrong. The science team is here, and just as of the beginning of the next fiscal year, we will be operating the entire program from Ames Research Center. And then the rest of the list are things that have already mentioned that impact all of our missions in heat shields and the robotics. And then down toward the bottom of the list, there's the Solar System Exploration and Research Virtual Institute and the NASA Astrobiology Institute. Those are the other two virtual institutes that are contributing to our capability to bring the entire world community together. Kepler, this is the exoplanet hunter. You may have heard a lot about it already, so I won't belabor the point, except to say that it's a tremendously successful mission. doing transit photometry, staring at one little region of space to look for variations in the brightness of stars that might be associated with a planet transiting in front of the star. And through a lot of independent observation and data reduction, we can identify and conclusively determine the size, the orbit, and composition of many of those planets. Now, our creativity came into play recently when the nominal Kepler mission suffered a failure of 2 of its gyros. It has 4 gyros. One was redundant, so we had 3 gyros to control the 3 spin axes. And due to a defect, the 2 of the gyros failed early. Well, with only 2 working gyros, you can't stabilize all 3 axes of the spacecraft, and it looked like the mission might be lost at that point because it is a critical requirement for extremely stable pointing for this spacecraft to achieve its mission. Through a lot of creativity, our engineers and scientists here figured out how to do this. With 2 gyros, still stabilize the spacecraft and continue its mission. That's why we call it K2 now. And it is continuing. It's lost just a little bit of scientific productivity, but the mission goes on, and K2 is now continuing to find lots and lots of exoplanets that give us a lot of inspiration about where we might go looking for precursors of life elsewhere. Partnerships are a big deal. I've mentioned the community here, and we really benefit from all kinds of near neighbors who have either related interests or synergistic interests with us. And you can see many of them here. It includes the great universities we have here, the large companies, the non-conventional ones that are working in high tech, as well as government partners. So through this combination here within just our neighborhood, we can work together with lots of people who help us be creative and innovative. In the research park, we've got over 100 entities represented, some of them here, that are working with us to accomplish our goals and also pursue their own goals. And looking more broadly, and I'll point out this one virtual institute as a particular example, we can network internationally with these virtual institutes that really are not a physical large institution, but rather networking through social media and internet connections and video connections to bring the greatest minds together and build diverse teams very quickly to address fundamental problems. And in the case of the Astrobiology Institute, how cool would it be to say you're working on questions like these? What is the origin and nature of life? Where else does it exist in the universe? Where should we go look? What was the habitability of early Earth? Profound questions, and the Astrobiology Institute is helping us with those. The other 2 virtual institutes, Solar System Exploration and Aeronautics, are similarly approaching profound questions in their areas and using that same capability to bring the entire community together. So now put your binoculars on and let's look even farther ahead. I just brainstormed a short list here of where I see the major themes of Ames contributing to the future of the agency and where we might go in the future. So I've said it a few times already, autonomy is a big deal. It is one of the major enablers for aviation, aeronautics, space exploration, life in space, and we have a great capability here that it will be used in greater focus to all of these missions. And specifically in the aeronautics arena, pilotless flight. Now that drones will be delivering your Chinese food in years to come. I guarantee you that. We're going to figure that out. Everybody wants it, right? So drones are the one instantiation of pilotless flight, but the next one would be passenger aircraft or cargo aircraft. FedEx would like to experiment with this with us. So they would be a great partner looking at cargo applications of pilotless flight. And eventually, I do think that we're going to take a look at pilotless flight for passenger aircraft. Using our earth science capabilities, climate change impacts are going to be very important. Sea level rise, temperature rise, drought, All of these things are very important for us to understand so that we not only can continue to live comfortably where we are, but we can ensure that everyone on the planet has a quality of life. Supporting the commercialization of low Earth orbit. That very good success story so far, and I think we're right on the cusp of lots of commercial opportunities, not just tourism, but commercial applications if it's developing unique materials and also potentially pharmaceuticals in microgravity that we really can't do here in the gravity environment. Robotics, space, science, and exploration, I think I've said enough about that already to explain that. We're headed for Mars, looking forward to it. We want to help. Quantum computing is an intriguing area that could be extremely revolutionary, and it might take us 100 years to get there. But once we do, it could change the way we do computing. I encourage you to look into it more. I am highly underqualified to comment on it. It's physics that I only briefly understood when I was in college, but it's a fascinating area. Data analytics is a big growth area, and that's where we can really leverage our local community to be the leader for the agency. Space biology, a major importance to us in understanding where to look for life as well as how to live. And just finally, we want to be the innovation center. We are already, and we want to keep doing it. 75 years. This is another 3 hours talk here that I could give. You can look back 50, 60 years or more and point to examples where Ames has had the culture of innovation that has enabled all kinds of capabilities that have become absolutely crucial to the success of the agency. So I think that this is our legacy. We've got a great future. Let's go make it happen. Thanks very much for your attention.
Thank you, Tom, for an excellent talk. We have time for questions. If you have a question, please raise your hand, wait for the microphone, and ask just one question. Thank you.
Hi, is it on? I was wondering, is it possible they could commercialize the sphere that was floating around in the spacecraft? I mean, as much as I like the Roomba, I would love to see that sphere floating around my house doing jobs.
So we're going to have to work a little bit harder on how to levitate in that situation. I mean, it's not a pejorative thing. We could figure that out, and that would be a nice personal assistant to have around your home. To have it float next to you is either going to require it to be lighter than air, and we have a little bit of experience in that, or figure out how to repel the force of gravity. But absolutely, and we do look for commercialization partners when these things come along so that we can take what we've done and let life on Earth be better as a result.
So it was just announced that Mike Suffredini's leaving, right? And it impacts quite a few things that we're doing, right? But specifically, from my own knothole, right, the human systems integration work that we do. And you mentioned we did the mission planning systems for MSL and all the other ones, and that got transitioned with a lot of direct input from Mike to first mission control planning of crew activity. But now just this week it got radiated up to the space station for the first test on station to look not only at crew efficiency but at enabling deep space missions where you can't talk to Earth, right? Can crew plan their own time? And I guess I do worry a little bit about that change. So I don't know, it's sort of a crystal ball question, but I don't know anything about the person who's taking over. Do you guys have any intel?
I can't tell you too much. It's very new information. I have met the gentleman once. He was a deputy center director up until recently, and so he was part of my peer community. And we just hope we have good knowledge transfer from Suffredini to Kirk, and that they've recognized our contribution, and we also have good relationships. So I think it's time for us to start talking to the new guy about all the great stuff we have done and what we can do. Everybody knows there's a free lunch, doesn't they?
Okay,
There's
so,
one more up there, I guess.
right.
The question is about partnerships, and from your experience of doing partnerships with the commercial sector, I wonder if there are any that stick out to you as really good, strong partnerships, and what do you think are the principles of a good partnership if you were looking to do a new one?
Good question, thank you. You know, we have a great opportunity here to partner because we have the NASA Research Park. So not only can we strike a deal, but we can co-locate here. And that's something that we are somewhat unique within the agency in our ability to do. So we have used that to good effect so far, and we really want to focus now in the future on being very strategic about who we bring this limited resource in to do unique things that you can only do with co-location. Clearly, any partnership flourishes on mutual benefit. We know where we're going. We want to understand where our partners are going and where that intersection occurs. Sometimes it's a fortuitous alignment of capabilities. For example, in high tech, data analytic capabilities benefit commercial interests. They also benefit NASA interests. And so we can work together on things like self-driving cars or autonomy technologies or data mining, and we both come away with something that's very successful. Others flourish based on a technology transfer, where we work together to accomplish something that's fairly focused on the NASA mission, but once that capability is established, it can be diversified into commercial products. And so those are really two of the key attributes that we look for, that we have a partner who's willing to acknowledge and work with us on our mission, and we will do the same with them. Kind of a generic answer, but I think that all those that I showed you there are examples of where we could explain what we got and what they got, and that's a pattern we continue to follow.
Okay, hi Tom. So thanks very much for sharing your insights there. My question revolves around the idea of how to be an innovative center in a conservative agency. And so part of being innovation means, or having innovation means that you've got to accept failures. Accepting failures is not something that NASA does well as an agency. And so you have to end up walking kind of a tightrope, and I wondered if you could tell us a little bit about how you think that's going to work in the future.
Thank you for that incredibly difficult question, Tom. I think that it is possible to be both aligned and innovative. That's the discussion that we had with headquarters when Eugene and I were kind of coming on board is, what do we do here? Do we, do you want us to be more, straight and narrow, or do you want us to just always be out there? And the discussion led to, we want both. We want alignment, and alignment means that we are clearly supportive of NASA's overall direction, but at the same time be innovative. And I can share with you that we both were implored early on not to have this pendulum swing too far back. They really see Ames as the innovation center, and they want us out there. And there is a more vigorous dialogue these days about what it means to accept risk. So we want to be responsible in the way we accept risk. We don't want to imperil people's safety, and we don't want to spend the taxpayers' money foolishly. We want to deliberately take risks where they are warranted, where they have a high payoff, and that we would acknowledge that when you take high risks, you're going to have failures. So the dialogue is increasing, and that's a little bit promising, that we need to test that premise and know that we're going to fail once in a while, and that should not have negative repercussions. So how do we do that? Eugene and I are working with the center leadership to make sure that we're aligned. So we're kind of going through all of our capability areas that I went through and the missions, and seeing that we have a relevance to those NASA missions. That's going to take care of the alignment part. Now we need to keep the focus on the innovation part, but be able to trace that back to these aligned missions that we're going after. So we're doing a lot of things, working with outreach and education, bringing interns in to keep us, really refreshed and energized. And we're just going to be looking at all the mechanisms that we can pursue to foster innovation. Hopefully we'll bring those together, and we need all of your help to make that happen, because any one person will tend to get stuck in their ways. So we've always been a little controversial as a center. We're going to keep doing that, but we're just going to show how it matters to the agency.
My question you kind of answered a little bit of it with the last question. With the future of the center, what kind of ways are you kind of guaranteeing, for bringing in new, fresh minds out of the universities and things like that to kind of help promote a more innovativeness on the center? I know that a lot of times whenever we're exiting university, it's 3 to 5 years of experience, but where do you expect to offer more opportunities for people who maybe don't have 3 to 5 years of experience as well?
Mm-hmm. I'm very empathetic to that. I have recent college grads who apply for jobs, and the first question often is, well, what experience do you have? And you're kind of like, what do you expect? I just got out of college. How do I have experience? I would respond to that first by saying I said we were working to align the center. One of the areas that we're looking at is trying to envision the workforce of the future. So we're talking about the future now, and let's say we're talking about the Mars mission. That a lot of the technology work for that mission is going to be done in the 2020s. We need a workforce in 10 years or so that is going to have the capabilities and attributes we want to make our contributions to that Mars mission. So we're starting with a little kind of envisioning, what does that workforce look like? And then looking at where we are and what does it take to get there. It's going to take a lot of mentoring and knowledge transfer as we pass capabilities from one generation to the next. We're going to need to be very deliberate about the skill sets and interests that we're going after, so that we reinforce our capabilities that we want to preserve, where we establish new capabilities that we believe are needed for the future. And that will guide us in our recruiting and our hiring strategies that we go forward with. So that's sort of the big picture philosophy and logic behind it. And with that information in hand, then we can very explicitly figure out where to go for recruiting. We want a diverse and capable workforce, and so we're going to have a better idea of where to go to get the workforce attributes we want. The senior management is going to be able to evaluate the opportunities better so that we don't get to hire all that much. So when we do hire, we want to be really confident that it's going to work. So we're going to be able to match the overall strategy with the approach that we're taking on any specific situation. In addition to that, we are delighted to host 800 to 1,000 students here every summer. And that's something that has created opportunities for the students in the future, and also for us to see what's that workforce going to look like and understand how we get ready for it. And so we definitely will continue doing that, as well as other outreach opportunities, so that our message gets out there, and the people who think they want to get on board with us can self-identify also.
So please join me in thanking Dr. Tom Edwards again for an excellent talk.